I think we can start. I want to welcome you here in St. Petersburg. I do not know whether you have been in Russia and especially in this city before, but I'm sure you'll like it because it's the right time to come here. The worst possible time is November because it's absolutely dark, raining, windy, no snow yet, so the worst time. But when April, May, and June come, we have midnight sun, especially in June. And the city is covered by mother-of-pearl's light, and you have the start of it now. So, and probably two words about the place where we are now. It's the former Bobrinsky Palace. And the first Bobrinsky was the son of our Empress Catherine the Great. When Paul I came to power, he gave a gift to his brother and gave the name of Count Bobrinsky, and this is the palace. So it was wonderfully restored these years, and now it places the College of Liberal Arts and Sciences, which is a part of St. Petersburg University, and we give a double diploma. One is from the Petersburg University, the other one is from Bard College, New York, which is also the College of Liberal Arts and Sciences. So the dean of this faculty is Alexei Kudrin, the former vice premier of Russia, who is now in exile, but we are sure he'll come back to politics soon. So my lecture, which I recognized this morning, which is not a talk but a lecture, so I changed several things. And I'll have a lot of text here so that you can read, not only listen. And the title is, as you see, Evolution of Cerebral Functions for Language, Phylo and Ontogenesis. And in recent years, dozens of books appeared that deal with language origins and language evolution and its connection to the brain. And it also deals with genetics and the search for human-specific genes goes on. And here are two more recent books. One is The Origins of Grammar. You can find books, The Origins of Words, The First Word, etc., etc. And a lot of conferences take place. Like some that I show you on the screen. One is the Cradle of Language, which took place in South Africa. And you can see several things that were mentioned there. Especially I want to show the name of Eric Royland, who's our friend and colleague in the University of Utrecht. We had a mutual PhD program. And he is the person of whom I'll talk a bit later. And all these conferences deal with recursiveness in human language. That is supposed to be the only one thing left, which is human-specific. But still there are people who doubt even this. It's about embedding, syntax, imitation, quoting, and theory of mind. It also is about proto-language, and I want to name Bickerton, and about autonomous vocal language with a largely non-essential visual component. Here I want to name Corbalis and Timothy Crow. Timothy Crow is a British psychiatrist who has published several very intriguing papers. The first one was called Is Schizophrenia the Price That Homo Sapiens Pays for Language? And he is publishing a lot of papers, and now there is no question about it. He states it as a fact that schizophrenia is the price that our biological species paid for evolution of language. So now we deal with such things. This is the picture in one of the recent papers, which shows diffusion spectrum, magnetic resonance imaging of the human brain, a three-dimensional structure of white matter tracks. This is how modern neurolinguistic and neuropsychological research looks like. This is what we can get and what we can show now. We also understand that in the majority of those who live on this planet, monolinguals are in minority, opposite to the common myth that bilinguals is a rare thing. Bilinguals cover the whole world, so comparatively small parts of the planet are inhabited by monolinguals. So the interest to this also is quite modern, and they used to compare brain regions that process language in multilinguals compared to monolinguals. An interest that is also one of UC Niemi's, at least in some years before, is about brain basis for simultaneous language interpreting, which is a critical, psychologically and physiologically critical process, because it needs wonderful working memory, it needs very stable psychic state, anti-stress abilities, etc. And for the brain, it's a horribly difficult task, because it's very quick code switching. So how the brain manages to do it is a special problem, and very interesting not only from practical points of view to teach those who are to become simultaneous interpreters, but from theoretical point of view as well. How the brain manages such a horrible job. So we all, at least some of you, I guess, know about Broca's area, which is announced as an organ of action orchestration. Areas 44-45 comprises sequence orchestration part in the brain. We all know it now, and a huge amount of experimental research is about aphasia and brain imaging of different levels of linguistic processing. These are the brains of Broca's patients, Le Borgne and Le Long, and recently these brains were processed by high-resolution magnetic resonance imaging, which showed that Broca's area is not in the Broca's area. So it appeared to be much more complex, but Broca, of course, he couldn't see it, as they didn't have such methods. Primak, a famous researcher, announced several years ago that human language is an embarrassment for evolutionary theory, because biology doesn't need language. Language is something which is individual and which gives you a kind of immortality, not biological but cultural. And individuality is something that is not supported by biological processes. Evolution doesn't need any language in our sense. Of course, all the living creatures have this or that kind of communication, but our communication code, which is not only communicational, but the code for thinking, and it's a very important remark. For instance, Noam Chomsky definitely says that language was supposed to subserve mentality, and communication is just secondary role. So, and we know that there are creatures that are able even to speak, like parrots. There are creatures that are able to learn human language to a certain extent, which are great apes, chimps primarily, and that there are birds, like crows of different kinds, that are extremely intelligent. Their intelligence is comparable to those of higher primates. Which is a separate and very interesting story, because their brain is absolutely different. For instance, they do not have cortex. So how do they manage to do almost the same things using a different apparatus? So what is human specifics? Is it computing brain? Of course, yes, but other creatures also can do it. Is it specific memory? Or its mechanisms? No, our memory is not specific. The others use similar patterns. Probably its structure, probably the structure of memory is more associated than that in other species. We simply do not know it. How can we get this information? I'm sure we cannot. Definitely, the memory is not a library. It is not stable. Files are rewritten every time when you recollect something, so you never get any stable picture. It changes all the time. And a different tapestry every time you look at it, because you recall only the previous recalling also. So definitely our human specific thing is human language, because human language is not the same but more complex. It's simply a different thing. The human fossil and archaeological evidence indicate that modern human symbolic consciousness is not the culmination of the long trend that natural selection could predict. Something happened, probably something which is called the event. All this shows that major change has been episodic and rare, so it was not a continuum. And that, as far as it can be determined from archaeological evidence, the step from non-symbolic to symbolic cognition is a rather recent event, as well as the event that couldn't be predicted. All this significantly postdates the acquisition of modern human anatomy. So our ancestors already had adequate anatomy, but for some reason they didn't have language, which is one of the questions. Why? Why they needed such a long time not to get the language? It appears that the neural capacity which is underwriting the radically new behavioral mode, arose as an incident in the same process that produced the new anatomical structure in our species. But for some reason, it was silent in a way until it was discovered by cultural innovation, plausibly by the invention of language. Invention of language is a strange term, but it is being discussed widely. So, in the case of the modern anatomical structure, it appears that the new capacity was expressed in Africa, as all of us know, and that its various behavioral patterns, quite various, were sequentially discovered in a drawn-out process that is continuing today. So the evolution of language has not stopped. The language is developing And a separate and very interesting discussion is about the trend. Where is it developing to? So some say that it's becoming more economical in a way, so that to give you the information in a quicker and less time. But it's not the fact, and there are opposite opinions, which I have no time, of course, to discuss. So my lecture is covering the field, more or less. David McNeill invented the concept of Mead's loop, which rests upon an idea of George Herbert Mead, who formulated in the early 20th century, which is strange, an origin hypothesis to portray what some 1/2 of a million years ago emerged in the evolution of human brain. He says that the mirror neuron circuits, and I'll come to mirror neurons later because they were discovered almost in 100 years later, that gesture first also assumes, but again with a difference. Mirror neurons in Mead's loop were twisted to respond to one's own signals. So Rizzolatti and Arbib were the people who linked mirror neurons to case grammar, a grammar of semantic connections such as action on object. A new way to organize sequences of movements in the Broca's areas were stated that are co-opting by language and meaning. So the mirror neurons also subserve shareable actions and other people's states of mind, which is called theory of mind. And of course I have no time to talk about it. So, so the idea of gesture first theory was proposed. It has many opponents, but still there are very serious and famous scholars that insist on gesture first start of language. So the initial form of language, they say, was in gestures, a sign language, or other non-spoken form such as mimicking and pantomime. And they say that speech evolved later, eventually supplanting the original gestures. But not everybody thinks so. There are very strong opponents. So, genes, we already had genes capacities that were to be used later. And we still have such a reserve for some future needs. We have so-called sleeping genes that do not act. And it is amazing, of course, because that shows that there, I'm joking, but still, that there might be some plan. Whose plan? What are these genes waiting for? For us to go to Mars or to some other galaxies where we shall have a different surrounding and we'll need different sensory possibilities, different types of coding, etc. So we have metabolically expressive large brains and huge intelligence. And the important thing is that human cognition came after human anatomy, as I said already. So if we ask when and where, we should also ask what we are searching for. Archaeologists, cultural and physical, especially physical, anthropologists, psychologists, geologists, physicists, anatomists, genetic people, all of them are trying to find our origins. Not only the origins of human language, but the origins of our species. But what should we look for? For bones, for behavior, for genes, for artifact? So it's a very vague thing. We should know what we are looking for, and probably genetics, which is very, very modern thing in this area, I mean, is the most important player. So all this happened in Africa by around 80,000 years ago, and probably before that. And probably the Cro-Magnons, who already had art, music, ornamentation, and other intellectual things, had very clearly crossed the critical thresholds of pre-human and human creatures. Of course, we have multiple mutual features with other animals, but we also have specific features like phonology, recursion and syntax, universal features that are probably innate, and just I'm hinting on Chomsky's principle versus parameters. A very important thing is context dependence. As far as I know, no other communicational system has such a dependence. In any other systems, 1 equals 1. In human language, 1 never equals 1, because the meaning always depends on a narrow and a broad context. So it's a very quick and very energy-consuming process. It goes online when we speak and listen. No stable fixed meanings, just semantic clouds or clusters. We have some prototypes and concepts, some of them probably innate, if to believe Jerry Fodor. And even the borders of such items are not stable and very subjective. So how do we manage to communicate is a puzzle for me. It is a code. So designed for what, as I said, for communication and for thinking. But we should also understand that we have such a very different from all the others ability as arts, in a wide sense. Arts, poetry, and the effect of such ways of perceiving the world and organizing the world is not less mighty than mathematics and linguistic codes. Sagas, myths, Greek and Roman literature all shows us the world not less mighty than 2,000 years after. So we are symbolic species, as Deacon says, and if you haven't read the book, do it. So Deacon and Chomsky contradict. We have different other intellectual things that are important and connected with the evolution of language, which is music, the strangest of all, very difficult to understand what it is. It is playing. Conventional plays are especially important for evolution of language. It's one of the scenarios for language, evolving of language. It's acting, like changing roles, using dialogues, and later it's producing virtual worlds, which we do, and as far as we know, because I have no idea how can we get such an information from other species, it's our own. We invent the second reality. So, of course, memory and memetics, following Marilyn Donald, is a very important thing in the evolution of language. Extremely important is inventing external memory of any kind, not only writing and consequently reading, but sculptures, dances, rituals, all that is very important for immortality. Sorry for the pathos. Because it's the only way we can prolong what we have invented. So the information doesn't die together with biological substrate, which is the brain. Of course, mathematics. Mathematics is not just counting. It's a very difficult intellectual process. It's condensing information and producing increasingly economic coding. And we are not only sapiens, and not only sapiens loquens, but also legens and scribensque. And I have to skip it because of the time, but one passage is important. We do descend from the ancestors that were not only non-linguistic, not they were rational in the way that we are now, but they were not planned to live in the 21st century in the middle of Manhattan. So when we compare our intellectual abilities to those of our ancestors, we should understand that we should be very, very cautious. We shouldn't seek for the same things. So, huge computational capacities are needed to subserve such functions. And the discussion about nature versus nurture, so genetic background versus what was acquired, is becoming much more productive when we use this genetic mirror. So now we can say what is genetically based and inborn. Was it the mutation and the event of grammatic explosion, or was it an evolution? Is the point of huge discussions that are never ending. Want to draw your attention to a book, From Molecule to Metaphor. Feldman is one of the founders of the theory of neural computation, which was developed with Lakoff, who wrote a book, Neural Theory of Language, which was republished in 2009. And among other issues, this theory argues that all mental simulation is embodied, since it uses the same neuronal substrate that is used for action, perception, and emotion. Again, I have no time to comment it, but I should say that it's a very important point which is absolutely neglected by specialists in artificial intelligence who want to produce anthropomorphic devices or programs that, by the way, do not have body, and they do not have information about the body. They do not have qualia, and so they look as if they are anthropomorphic. I mean, not visually, but in the way they process information. Have to skip it. So what we know now, it's again a never-ending dispute about whether language is something which has modules in the brain, or a connectionist viewpoint wins. We know that cortex is a network. No modules or blocks. It's evident. However, Broca and Wernicke areas exist, and all the clinics of the world get evidences of this, unfortunately, every day, if not every hour. We also know that cortical representation of knowledge is in general is a network. We know that memory is a network. We know that language uses the same cortical structures and processes as other cognitive skills. So it's very difficult to catch it when it's just language, because it's never just language. It's also associations, working memory, long-term memory, attention, etc., etc. But phonetics, it has specialization, and probably it is that was caught by Broca and Wernicke. Now we know a lot about neurons as units. We are starting to know how they work together. We can even see it. There are techniques that can see a functioning neuron online. We know about functional blocks. We know that there are no modules. We know that there are some localization and a lot of spread activity. So, I want to draw your attention to Edelman, who is a Nobel Prize winner, with his paradigm of neural Darwinism, the theory of neural group selection that was further developed in his book Second Nature, Brain Science and Human Knowledge. It's similar, for those who know, with Hebb's approach to functioning neuronal ensembles that gather together when they want to fulfill some task, and then they go back home to the places where they live when they are not functioning. But it's a long story. A quantity of neurons is amazing, and it's changing all the time because we see more, and it happens, it appears to be still more dramatic. So it's 1 trillion neurons in the human brain, and a quadrillion was a fantastic sum of synaptic connections. So the net that we have in the brain is the most difficult and impossible things that we know about. It can be compared only to the universe. So we are hunting for the human genes. We want to know whether it was evolution or mutation or creation. I'm joking. Many features are in common when we compare different species. But Hauser and co-authors wrote, the human faculty of language appears to be organized like the genetic code. It is hierarchical, it's generative, it's recursive, and virtually limitless with respect to its scope of expression. So, several genes appear from time to time, almost every other day. The most famous was FOXP2, which was announced as a grammar gene, which appeared not to be so because we share it with other species like cats and even crocodiles. FOXB1, which is the gene, the collapse of which disturbs working memory, which is a very important thing for language, of course. And the whole group of genes, which is called Human Accelerated Region Forward Genes 1. It's a hub. So it's a specific genetic group that caused acceleration of the frontal regions of cortex in our ancestor, and it developed a pause 70 times as quick as the other parts of the brain. I simply couldn't believe it when I saw it. I thought it was a mistake, probably 7 times, which is also amazing, but 70 times. That gives that evolution was not equal, was not equally active in different parts of the brain, to say nothing of the whole organism, but we are talking about the brain. So what did it give us? It gave us quick computation. It gave us recursion rules. But recursion is acting not only in linguistic processing that subserve mental lexicon and grammar, but it subserves social behavior. Not only. A famous paper for, not for students, but for specialists, of course everybody knows this, very famous paper. A huge discussion concerning this text is continuing. It's Hauser, Chomsky, and Fitch, and it is called The Faculty of Language. What is it? Who has it? And how did it evolve? So Chomsky divides the faculty of language in this paper into 2 main groups. The faculty of language in a narrow sense, which he says is the only uniquely human component of the faculty of language. And a component which is a faculty of language in a broad sense, which we share with other species. It's very strange for Chomsky to announce such a thing, because he is, as you I'm sure know, he insists on this huge gap between us and all the others. So it's a strange step, and it has a lot of discussions, some coming from his previous students, I would say, which is Steven Pinker and Ray Jackendorf, who object. They say that in that paper, the authors ignore the fact that many aspects of grammar are not recursive, and these are phonology, morphology, case, agreement, and some properties of words, which are crucial for our language. They also debate with Chomsky, where universal grammar is described as a set of attractors causing the human capacity to learn the language, to learn any language, on the basis of the assumption that everything is already there. So the Chomsky school insists that the language is not acquired, it is developed from the root that we already have, and it is inborn. Of course, it is influenced by the surroundings. Of course, input is the most important thing, but only after we have the genes. So they argue that it is hard to imagine, I mean Jackendorf and Pinker, argue that it is hard to imagine all this structure emerging in the brain prior to experience, much less being coded genetically. So it's not the stated fact. It's a discussion between very strong groups of scientists. So a core of neurosyntax, in Chomsky's sense, is opposed to combinatoriality spread across the brain. I want also to remind those who studied some biology about the so-called recapitulation theory, which is also called the biogenetic law or embryological parallelisms. And it is about the fact that ontogeny recapitulate phylogeny. It's a hypothesis that in developing from embryo to adult, animals and humans go through stages that are representing successive stages in the evolution of all the ancestors of this species. This is important for our topic because in neurolinguistic and psycholinguistic research, first language acquisition and language pathology are the main players, because this is the place where we can get the information that gives us hints on how it all happened in the beginning. So children show features and processes that resemble a lot what we had in the beginning of our history, as far as we know it, of course. So, there is a very famous physicist, Freeman Dyson. In his Nobel speech, he classified mathematicians and physics as either birds, high-level theorists and synthesizers, or frogs that are empiricists and problem solvers. So he says he opposes those who come after Descartes, which is Chomsky in our sense, and opposed to Bacon and all the others that prefer empirical work. So he says some mathematicians are birds, I'm citing, others are frogs. Birds fly high in the air and survey broad vistas of mathematics out of the far horizon. They delight in concepts that unify our thinking and bring together diverse problems from different parts of the landscape. Frogs, the opposite, live in the mud below and see only the flowers that grow nearby. They delight in the details of particular objects, and they solve problems one at a time. I happen to be a frog, Freeman says, but many of my best friends are birds. Mathematics needs both birds and frogs. The same trend is in linguistics. Functionalists definitely come from Bacon, while generativists they simply announce it, that they come from Cartesian paradigm. In linguistics, we definitely need both. It's a non-ending battle between generativists, which are primarily from the American continent, not only, of course, but mainly they come from there, and generativists and functionalists that cover all the rest of the space. They simply hate each other, because generativists say we do not need these small facts, we are searching for algorithms that are universal for human species in spite of tremendous differences in languages. We have around 6,000 languages on the planet, and as we know, they are very, very different. Some have 8 phonemes, some have 84 phonemes. And the structure of language is extremely different. But generativists, they want to find universal features that are still there in spite of all the differences. While their opponents say these Chomskyan people, they do not know anything about languages. They are working with their mathematical tricks. It's all nonsense. They should better look at the data that we have. So, of course, we need both, and hopefully we are moving in that direction. And I thank you for your attention.